Okay, thank you for having me. I'm Elizaveta. I'm going to talk about understanding smart contracts. This is the joint project with Raphael Reule and Professor Herdle. Another, so to say, coding name of this project is Hype or Hope, because recently all of the cryptocurrencies and smart contracts have gained a lot of popularity, and we can see here on this slide, this is the CRIX. CRIX is the cryptocurrency index, the first cryptocurrency index made within academia. It also was made within our university, so to say, within our department, and now we have Blockchain Research Center. And also, just to make a small introduction, everywhere you see the sign Q, it means that the code for this plot is available online, since we are kind of advocates of reproducible research. So, again, as I mentioned already, cryptocurrency have gained a lot of popularity. And one of the pioneers and the players we most talk about is the Bitcoin. Here we can see the performance within the time, and we can see the huge spikes within 2018 and within 2020. But why is it so popular? It's out of the scope of this talk, but we will talk about the Ethereum, so to say, the second player. It also has gained a lot of popularity within 2018 and sorry? Sorry, do you have a question?
Yourself.
Anyways, Ethereum came to the market with the idea that it won't only promote the ability to have cryptocurrencies, but also with the methodology of smart contracts. And what are they? This is basically the idea of our talk. So, so what are the smart contracts? They are also known as crypto contracts. They are computer codes running on top of the blockchain, containing a set of rules under which the parties to that smart contracts agree to interact with each other. They automatically execute themselves, and the idea of them comes from basically the same idea as with Bitcoin and any other cryptocurrency. We want to avoid using some central third party to interact with our with our peers. And if Bitcoin could be seen as gold, we're exchanging the money. The smart contract, the Ethereum, is seen rather as oil, because it's not only allows you to exchange the Ethereum itself, which is also is bonded to a lot of money, but also it create the opportunity to create your own cryptocurrencies on this blockchain, and also to create other contracts, which are here smart contracts. So, but they're not so smart, as we will see. It's still about the motivation. 2017, 2018, smart contracts came to the market, and everywhere you could see about the ICOs on Ethereum, and not only there. So, and then more and more startups, so to say, were presenting themselves. Most of them at this time were related to finance. But however, if you Google or search on the internet on smart contracts, you will find, I don't know, TED Talks or a lot of visionary content about how can we exchange houses, marry, or get a rental contract with using Ethereum, or even create a transplantation donor registry. Is it the functionality that we can truly use, or is it still just the financial vehicle? On this slide, we can see the total smart contracts introduced on the Ethereum platform since the beginning, and we can see that there are about 4 million of them for now. So the behavior is quite similar to the Bitcoins. 2018, it was gaining popularity, but I will come to this slide again later. So Ethereum is made or claims themselves that they can basically execute almost anything. This is the computer, decentralized computer that is capable of executing almost anything. And on the right hand side, you can see the picture of cartoon cat. Why is that? It is one of the most popular decentralized apps on Ethereum's blockchain called CryptoKitties. And there was a period of time when it was taking up to 10% of traffic. So basically 10% of the most powerful computer was executing the transactions of people exchanging cats and gathering the heads for cats and colors for their clothes, etc. So is it something that so visionary where we can do the organ transplants using this registry, or rather it's just some hype where we can do either finance speculations or exchanging cats? So the first idea is to look into the research. If we just go to the research of Ethereum smart contracts and load all of the available research in English and see the keywords, we will see again the same buzzwords: security, Internet of Things, Bitcoin, consensus analysis, solidity. So it doesn't really give you any understanding of what is going on there. So we decided to look closer into this academic research. And basically we created the topic modeling for the abstracts of the research and reduced dimensionality and made some clustering. And using the elbow curve, we identified the proper amount of the topics, which is 14. And here we can see that there are different interesting topics about healthcare. Quite a lot of papers are about healthcare, which is also kind of goes along with the motivation of people on the internet to promote like very visionary things like healthcare blockchain with Ethereum, etc. Agriculture, food, some sustainability. There are some papers on vulnerabilities and Ponzi schemes, which is quite expectable in this area, about energy and voting and auction and other things. But anyways, what we want to say here is that research is concentrating on many different topics, not just on finance. And research questions, there are quite many, but to summarize it in a couple of sentences, we want to see whether, as I mentioned in the beginning, hype or hope. Is it just financial vehicle, or we can do more with it? Or do we want to do it at all? For example, here on this slide, we can see that 90% of simple financial transactions and 10% are exchanging cats. So this was to motivation. What is smart contracts? Again, I told you that it's just computer code running on the blockchain. This is basically just set of rules, protocol of rules that people can so people can communicate with each other and with the system, enforcing some agreement, for example. It can be used for rental contract, marriage, certification, voting, game payouts. At least this is what usually people say when they talk about smart contracts. This is an example of real estate transfer. It's, for example, we can exchange the registry with Ethereum, and when certain conditions are met, for example, Bill will receive the money. Ida will automatically receive the house ownership, for example. Technically, it's just a piece of software, one smart contract. We can see that it has quite almost the same structure as any object-oriented programming language. We have classes, constructor, functions, even comments. So it's just the code, just algorithm which has a specific behavior. Legally, it's a non-physical agreement, blockchain application. It's not really a contract in a legal sense. There are two types of Ethereum contracts. There are either accounts, they're called wallets, basically some sort of physical people, and the contract accounts. People can exchange the transactions, even if some researchers or industry say that smart contracts can even create other smart contracts themselves. It's not completely true. Only people can create transactions that will kind of trigger other smart contracts. So always in the beginning of on the chain, there is a personal account involved. So we cannot create a transaction between smart contract to another smart contract without involving one person. So again, the slide, total contracts, I said there are a lot of them. And this is the plot on state of the dApps. We can see quite similar trend. dApp is the decentralized app. Basically, it's a set of different smart contracts which are listed on this website. So they are marketed, so people can know about them. And as we can see here, there are 3,500 of them on Ethereum. And if we go back, and one decentralized app can contain either one or multiple smart contracts. So if we see what are these transactions, what are these smart contracts on the blockchain already that are listed, we come to this line, this line around 0. So basically, we don't know anything about Ethereum blockchain. Everything which is listed and everything which is really used is rather around 0. So what can we do about it? We can, to get a better understanding, we can gather the data on the codes, so to say, the source codes, and we can try to build a classifier. So this is the description of the data sources we used. So source code, if, for example, preprocessed in a certain way, can look like this. So it can be treated like a text. So you would use the same procedures as for basically NLP, natural language processing, but for the code. So it's quite similar. Here we can see different amount of features that can be used to model a certain amount of smart contracts to see how good we can basically separate the classes. Because when we build a classifier, the thing we are interested in is the separability between the classes, since we are trying to find the representation where they can be easily separated. And also on the right side, we can see that the biggest category is games, then exchanges, then we have quite a lot of finance, then gambling, marketplaces. We also have category of high risks, which are mostly Ponzi schemes and other high risk smart contracts. For example, high risk, there was a DApp called Forsage, and then it was about like 10% of the all transactions on Ethereum, and then they found out that it's just a Ponzi scheme. So it looks like a lot of transactions on the blockchain are just related to the high risk behavior. We decided to use AUC and average precision. As I already shown you, we can treat the code as the text. So we ran different machine learning and statistical learning model algorithms on the code, on the comments, and on both, and measured the performance. And what we could see, interestingly, there was no type of features that was always kind of better than the other. So we cannot say that always code or both means more information, means better class separability. No, it's not like that. But on the other side, we could see that the classes with a higher amount of observations would get a better performance. On this slide, we have average precision. It's a metric which is more related to skewed classes. So it was also interesting to see here. And then in the next step, we wanted to...
You have 3 more minutes. Sorry,
okay.
3 more minutes.
Actually 4, no, but yeah.
Oh, okay.
If we apply this information on the data, on the unseen data, how it would look like. And what we see, it's indeed the most of the smart contracts are on finance, and other that are related to some healthcare or agriculture are not so, don't have that amount of observations in the end. What is interesting, we can see also quite good clusters of games, and high risk is not that big of a category, which is good. Here we can see the behavior, so to say, amount of transaction within each category. But the last point about the popularity of Ethereum and blockchain applications is sustainability. A lot of people talk about sustainability and how it is important. So this is the amount of transactions on the Ethereum. So it's close to 1 billion. If we can see in another research, almost 67% of smart contracts never received any transaction, and 94 received less than 10 transactions. So there are a lot of contracts, there are a lot of things lying around on blockchain which are never used. On this slide, we can see it's also a little bit related to sustainability. The block time, basically block time is the time which needed to mine to validate a transaction for the blockchain. And what do you think is this spike? Yes, these are the cats which we mentioned before. And so, as I said, a lot of energy, time, and computational power goes just into cats or other not very serious things. And this is energy consumption. I'm not very familiar in general with energy, so we wanted to see how is it a lot or not. So basically, annualized total electrical energy of Ethereum is comparable to the power consumption of Zambia. The data comes from the Ethereum energy consumption. It's based on a research paper of one researcher. And one transaction of Ethereum, the energy consumption to get this transaction is comparable to the energy consumption of US households for 1.1 days. Is it a lot? It's a lot. But if we see to the Bitcoin has even more. So Bitcoin transaction can be compared to 23 days of household energy consumption of from United States. So it's a lot. But to be fair, I need to mention that Ethereum is trying to get more sustainable, and they are introducing Ethereum 2.0, which is based on another consensus algorithm, proof of stake, which should be more sustainable and require less computational power. So in the end, hyper hope, we still could see that the most of the observations are related to finance, and consumption and energy consumption is a lot. So can we have, is it just a financial vehicle, and can we invest in cryptos and use blockchain in context with sustainability? That's it. Thank you.